Prime numbers have baffled mathematicians for centuries. Paul Erdős said, God may not play dice with the universe, but something strange is going on with prime numbers. In this video, I want to share with you two properties I saw on Twitter about the neighbors of primes. The link to the tweets will be in the description below.
The first one is, every prime number greater or equal to 5 has a neighbor that is a multiple of 6. Let's look at some examples. From 4 to 24, the 7 primes in this interval are next to a multiple of 6. However, this is not near enough evidence for a mathematician. It must be true for all prime numbers. The goal of this video is to convince you that this property is true without needing to check all primes, since doing so would take infinite time. So instead, we'll look at the general prime p and its neighbors, p minus 1 and p plus 1. To start, we want to find multiples of 6. So what do we know about this number? The most important thing for us is that 6 is 2 times 3. With this simple fact in hand, we can transform our task of finding the multiple of 6 to finding the one that is both a multiple of 2 and 3. It may look like now we have doubled the work, but in reality, we simplified the problem. Think of it like this. Since p is not 2, then it is an odd number, so the neighbors are even. In other words, p minus 1 and p plus 1 are both multiples of 2, so our job just got simplified to find out which one is the multiple of 3 instead of 6. Let's start by looking at the first multiples of 3 and trying to find a pattern to help us. Between successive multiples of 3, there are two numbers, so our prime p must be somewhere in this pattern. So in the general case, we have this. Since p is a prime and not 3, then it is not in one of the extremes. So it is either the first or the second value in the middle. In the first case, p minus 1 is a multiple of 3. In the other case, p plus 1 is a multiple of 3. We have everything we need now. We know that both p minus 1 and p plus 1 are multiples of 2, and one of them is also a multiple of 3. Then 1 is a multiple of 6. We just saw that every prime is next to a multiple of 6. So now let's see one property that at first glance might look even more out of nowhere than the first one. Every prime p greater or equal to 5 has the property that p squared minus 1 is the multiple of 24. First, let us test it with some prime numbers. For 5, 7, 11, and 13, we have that p squared minus 1 takes the value of 24, 48, 120, and 168, all of which are multiples of 24. But how is this property related to the neighbors of p? Well, it turns out that p squared minus 1 is the multiplication of p minus 1 and p plus 1. The next step is to analyze 24 like we did with 6. We know that it is 2 times 2 times 2 times 3. But it will be more helpful to write 24 as 2 times 4 times 3. We already know that both p minus 1 and p plus 1 are multiples of 2, and that 1 is a multiple of 3. So for the product to be a multiple of 24, we just needed one of them to be a multiple of 4. Let's look at the number line. For successive multiples of 4, there are 3 numbers in between. The middle and the extremes are even numbers, so r prime p cannot be there, and only has 2 options left. On the first one, p minus 1 is a multiple of 4, and on the second one, p plus 1 is a multiple of 4. We now have all that we need. One of p minus 1 or p plus 1 is a multiple of 3, and one of them is a multiple of 4, while the other is a multiple of 2. Therefore, that product is a multiple of 24. In other words, p squared minus 1 is a multiple of 24. I hope you found these properties as interesting as I have. If you have any math topic you'd like me to make a video about, please drop your ideas in the comments. And also, don't forget to like and subscribe to the channel if you want more math videos.